Hi, and welcome to SQL Bits. My name is Tom Lester. I'm a cloud solutions architect at Microsoft, and I specialize in databases and machine learning. And today we're going to be talking about machine learning in Azure and the Python SDK. So this session will be reasonably demo heavy. Now, there's lots and lots and lots of stuff in that we do in machine learning and AI. So we're only going to touch the tip of the iceberg here, but I'll try and give you a complete picture of all the different stuff. We'll go through some slides and then we'll jump into demos and I'll show you what machine learning studio looks like, and we'll do some demos around AutoML and how you create experiments and record all the data from those experiments. So let's start off by talking about, if you're doing any machine learning, what you might need in a machine learning platform. Now, any machine learning project, you'll need to go through several stages. You'll need to prepare the data, you might do feature engineering, etc. You'll need to start doing your experimentation, and then you'll need to be able to deploy those machine learning models into something, which and traditionally this has always been quite a complicated thing to do. Lots of different skills involved in this. You need data scientists, you need people that understand how to do the deployments, you need people with computer science degrees, etc. And you need some people that understand the data and are able to wrangle that data into the shape to push it forward into training your models. So um, all of these steps obviously need different roles to understand traditionally, and you need something to orchestrate all the flow through of these steps. Because with any project, be it just a standard computer science project or a machine learning project, you want really to have be thinking about DevOps in relation to it and have repeatable pipelines to push your code out and deploy that code. Um, So DevOps loop for the data scientists, of training in your model, then you'd register your model, you'd build an image. So this might be using something like Docker and pushing it out to a cluster like a Kubernetes cluster or something like that. Um, one of the more common ways of doing it, not the only way of doing it. And you'd want to monitor your model. You'd want to understand if your data is changing, understand when to retrain your model, and so you'd also want to start moving around this loop multiple times. We have it as a circle because your data will change. Any machine learning model that you maybe trained a year ago, if data's moving, you probably want to think about retraining that model. So machine learning is always an iterative process. A machine learning project never really stops. You get to a model, but as soon as that model's developed and you have a level of accuracy, that level of accuracy is going to deteriorate generally as things change and stuff moves on. So, any kind of good machine learning solution, you'd need to be able to containerize your models, put them into Docker images. You'd need to have some versioning in place. You'd need a model repository, and you'd need to be able to track your experiments. So as you can imagine, all of these things, what I'm leading up to is that we cover all of these approaches within the machine learning platform. So I'm going to show you, like I say, try and show you most of these things, but in the time we've got, obviously can't show every aspect of that. Now, machine learning on Azure. So we have lots of different ways of doing machine learning and artificial intelligence. Like I said, today we're going to be covering Machine Learning Studio and the Python SDK. We do have an R SDK as well, but we'll be covering Python just due to time constraints. And Python seems to be the more popular language at the moment. Obviously, R has got many advantages, but most of the stuff we're seeing being developed is in Python as well. Okay, so in terms of our estate, in terms of the Microsoft AI estate, we have domain-specific pre-trained models, which you can actually run in SQL Server. You can have cognitive services, you can do speech, vision, deep neural networks, etc. Not going to cover them in any detail. Just make you aware that they're available. So if you're doing a vision project, object detection, that kind of stuff. It's worth looking to as the pre-trained models and some of those cognitive services as well, such as custom vision. What we try and do is when we're everything we develop in terms of machine learning, we try and make sure that our machine learning is approachable and accessible to everyone. We're not inventing new learning languages, that we don't have a Microsoft Python that's different to normal Python. You can bring all your open source tools, all your open source knowledge to our platform, and we really just help you take your code and help you put that into and kind of ML ops pipeline, and take that code and make it easy for you to develop, make it easy for you to deploy, and just simplify all of these areas that you don't really want to spend time doing. So you want to focus on the development of your model, make sure you've got the best machine learning model out there. You don't want to worry too much about writing a ton of code to manage to manage all the DevOps ML ops of that. So we support all the popular frameworks, so things like PyTorch, TensorFlow, Scikit-learn, obviously. Onyx is a technology that we've been working with Facebook since, I think it was for the last few years, and that's Open Neural Network Exchange. It stands for, so the ability to run neural networks on different devices, different frameworks, etc. So in terms of being able to productionize, we have Azure Databricks. We're not going to cover Azure Databricks today. We'll talk about in passing. Most of the stuff we're going to be doing is using the Azure Machine Learning Compute and things like Azure Container Instances. We'll talk about a bit about Kubernetes as well. But all the stuff we're talking about, you could deploy on Databricks. You could deploy it locally. We don't hold you to having to run it in Azure ML Compute. It's just that's probably the easiest way to do it, which again I'll discuss as we go through it. And then you can also use your machine learning virtual machines as well, if you're familiar with them. They're VMs that you can just spin up, and they've got all the kind of toolings that you'd want on them. Things like SQL Server, things like RStudio, Python, etc., etc., etc. All pre-set up, so you don't have to spend. If you wanted a development environment, that gives you a development environment where you don't have to install everything. And then we have different options in terms of deployment. So we have CPUs, obviously. We have GPUs. So if you're doing deep neural networks, you can spin up N-series VMs as containers. You can spin them up as VMs themselves. And you can deploy onto them and start using the power of GPUs to do that. And we also have FPGAs, field programmable gate arrays. That's ready for deployment of your deep neural networks. It basically burns the model onto the chip, and then it's a very fast way of doing kind of image inferencing, that kind of stuff. I mean, it is the specific use cases. Most people will be going down the CPU and GPU, but it's worth considering FPGAs if you do have a very large scale image detection problem, these kind of things. Okay, so Azure Machine Learning Service. So we have our cloud services, and we have our Python SDK. But I'm kind of using Azure Machine Learning Service and Azure Machine Learning Studio interchangeably at the moment. It probably caused a bit of confusion in terms of, we used to have a technology called Azure Machine Learning Studio, which still exists as Azure Machine Learning Studio V1. That was a drag and drop interface. We've now had what we call the Visual Designer in Azure Machine Learning, the new Azure Machine Learning Studio. But you might also hear it referred to as your machine learning service as well. So anyway, we have that platform, and we have the Python SDK, and between them you have the ability to decide how you want to do your machine learning. If it's going to be a drag and drop style interface you want to use, if it's going to be wizard based, if you want to go straight down into coding, it's all accessible for you, and we try to make it as simple and easy as possible, because you don't want to spend a load of time just messing around trying to write code to spin up a VM and that kind of stuff. Okay, so it's all designed around the lifecycle. The lifecycle we kind of talked about earlier, being able to train your models, register your models, record your experiments, etc. Like I say, I'll show you that. Some of these slides I'll skip over a bit because I'm going to show you a lot of this stuff in demos. Um, we just talk about what we have. So Azure Machine Learning, how it works is you will create a workspace. That workspace holds multiple components. So within that workspace, you'll get basically it'll be a resource group in Azure, and within that resource group, you'll have blob storage. The blob storage will be there to hold any data sets, etc. You move up into there, hold all your experiment data. So if you run an experiment, all the metadata around that, and it'll also hold any notebooks. So if you're developing using notebooks, which I imagine most people would be doing in the data science project, it'll contain a copy of them. So the only bit that costs you when you spin up a workspace really is the blob storage. You can then choose if you want to spin up compute. So when we look at notebooks in a minute, you'll see that I have lots of notebooks. Those notebooks aren't attached to a compute. I can destroy compute if I want to. Those notebooks are held actually on blob storage, and when I spin up compute, I just move them onto that compute, and we run on it. So in our workspace, we have we have the key vault in there. So key vault's there to hold all the keys and control access to any external data stores that you might be connecting to. Maybe you connect to Azure SQL database, maybe you connect to a data lake. So it holds all those keys in there. And you can also use it to control your own keys in your experiments if you don't want your the codes and everything to get on to a third party or another service in Azure actually in your notebook, which is generally bad practice. You wouldn't really want to put any passwords in your notebook, so use Key Vault, which comes as part of the workspace. So within the workspace, in the workspace, we have models, which is stored. You have your experiments, so metadata about experiments you've run. You have your pipelines, which is your ML ops, so the ability to have repeatable run-throughs of training and inferencing. We have compute targets, which I'll explain in a bit more detail. Just different ways of being able to different levels of compute that you can run on. We have the images, so Docker images, deployment methodologies, and our data stores of data that we might be using to train our models or test our models. So this is a kind of breakdown of the Python SDK. Like I said, we don't have a huge amount of time, so we can't really go through this in too much detail, but we will cover all the main aspects of this. So things like being able to create an experiment, being able to run an experiment, things like deciding on your compute targets. We also have other bits in there which if we have time we might get to. So data wrangling services in there. And also as part of this, the ability to be able to operationalize your models. So we have our models. We have our model registry where we can store our models. This gives us the ability to then pick them up, put them into images, etc. We have our experiments, we have our runs, we have a run configuration. I'll gloss over this because I'm going to show you this through demos. We have our pipelines, which, like I said, ML ops, where we go through, and you can pause the recording and read the text. Like I say, so I'll gloss over these because I'm going to show you a lot of this stuff. Pipelines, why would you use a pipeline? So obviously you might want to do it unattended runs. You might want to, we have technologies in here called data drift. So we can see when, as data is being loaded, we can see when the data has drifted, say 20%, 40% away from the original set of data, and you might set up a pipeline that looks to see how much the data has drifted, and then if the data has drifted a sufficient amount, it might then kick off a model to be retrained. If for example your model, if you have a huge amount of data and quite a complicated neural network that takes a couple of days to train, you might not want to train that every couple of days. You might only want to do it once you've had a sufficient drift in your data, for example. So it helps you kind of automate all that. You can another advantage of pipelines is you can jump around different kinds of compute. So different bits of compute are good for different reasons. So Databricks is really good if you have large scale problems and you want to go over multiple nodes. We can still do that in Azure Machine sorry, ACI or Kubernetes, Azure Container Instances. We do support distributed training, so things like Hoverod and that kind of stuff. Um, but you can choose the different kind of compute that you want to run on as part of that, and use multiple computes depending on whatever fits best. Usability, tracking and versioning. Obviously, with any kind of MLOps pipeline, you would want to have versioning and tracking in there. Um, Okay, so and the pipelines you can create through the Python SDK as well. So different compute targets. So we have, and this sometimes can be a point that confuses people a bit. All the different compute targets that are available. So if you spin up so we have you can spin up on your local computer and do training on there. It's just a pip install Azure ML, and that will install all the packages, so you can start using the SDK. So you can run on your local computer. You can use a VM in Azure. These are ways of doing it. I wouldn't necessarily advise them. I'd usually say ML compute is going to be the easiest and best way of running it. And this is what we'll do all the demos in Azure ML compute. Um, So, and why is that easier? Because Azure ML Compute comes with packages pre-installed, so you don't have to set up your local environment to have. So yeah, of course, you might be using the Python SDK, but you might need to install Scikit. You might need to install Pineapple, Pandas, all of those kind of technologies. Get all the versioning right for the kind of problem that you're dealing with. Think about other things to install. Azure ML Compute is all there for you. I at one point I had about 10 different Python environments on my laptop. It was getting a bit confusing trying to remember which one was which. Now I just jump up into Azure ML Compute, spin that up, and I know I've pretty much got most of the libraries I'm going to need up there. And if I don't have a library on it, it's very easy just to do a pip install as well. So Databricks, discussed that earlier. We have Data Lake Analytics. I wouldn't necessarily suggest using that anymore. It's a little bit of a legacy. It's not really being used much in the industry now. We've got Spark for HD Insight and obviously Spark for Databricks as well, just depending if how much control you want over your cluster. Most people would probably, if they're using Spark, they go for Databricks now, just because of the it's much simpler than having to deal with a Hadoop cluster, which you get in HD Insight. Azure Container Instances. So you have your Azure ML Compute, which is where you're going to be doing a training. When we spin up a notebook, we're going to be running on ML Compute as well. If we wanted to then go off onto multiple clusters and run some stuff across them, which I'll show you with ML, AutoML, we would want to go off into Azure Container Instances or a Kubernetes service. So container instances work really well if it's something that you're going to spin up, do a bit, shut it down. So good for dev test style environments, good for doing training where you just need it for a bit. If you're gonna, you can run it 24/7, but it's more costly to do that. So if it's a 24/7 style project you're doing, most people go to Kubernetes. So the kind of general rule of thumb, ACI, Azure Container Instances, great for doing a training. Azure Kubernetes services, if you're going to spin up a web service and just have that as a web service 24/7, Kubernetes is the way to go. We also have the ability to create your models and run them on IoT Edge or deploy them to FPGAs, which we talked about earlier. Okay, so the kind of model management. So you'd create your model, register your model, create an image, deploy that image. And there are two different ways of deploying your model. So what's two traditional ways of doing it? You can deploy your model, pretty much any way you want to. You could use this. We're not Nothing we do here is trying to box you in to say you have to do it this way, you have to do it another way. These just we talk about the more common approaches. So you could use Azure Machine Learning SDK to create an Onyx model, and then take that Onyx model and stick it off on a Raspberry Pi and move that off without using IoT Edge or anything like that. But what is much easier and more common to use things like IoT Edge, use IoT Hub, etc., with IoT modules, or just to take it and put it on a web service. At the end of the day, what you're creating is you're creating either Pickle models, or you're creating Onyx models, or and yeah, they're just the most common two. Like I said, not boxing you in. So you can choose what you want to do with them, but we just make it easy to be able to deploy via a web service or IoT module. With this kind of, we've all got all the infrastructure and the code to do that. Now, we also have dataset profiling. If you've used the early version of version 1 of Azure Machine Learning Studio, this might look familiar. Ability to look at your data and understand your data in terms of the layer of your data. So you get a better understanding of there. Right, now we'll talk a little bit about Azure AutoML, and then we're going to jump into demos. So just to kind of give you a concept of what we're doing here. So with AutoML, we might have a problem how much a car is worth. So as a data scientist, you might need to think about, right, which features, I just need to start doing feature engineering, I need to think about which algorithm to use, and I need to think about which parameters. So this might, and this whole process here could take anything from half an hour to a year to do, depending on the problem. And obviously, if you're a data scientist, you probably favor certain algorithms that you're more familiar with. So you're probably going to start with them. For example, if you've been doing a lot with decision trees, you're probably going to be going, right, okay, let's approach this problem with a decision tree. And it might work, but it may not be the best way of doing it. So if you want to do a complete job to try and get your accuracy level, if we were looking at accuracy in this case, if you want to get your accuracy level as high as possible, you then might go, right, okay, let's look at support vector machine, let's look at naive Bayes, or etc., etc., etc. That's all very time consuming, and it's pressure to use all these different algorithms that are out there and understand how all these different algorithms, how to talk to them and set the parameters. So, and even once you've got an algorithm that works quite well, so you might have a decision tree, and the decision tree maybe gives you 80%. Then you need to think about, how many leaves do I have in my decision tree? How many iterations of the decision tree do I need to go through before I get the best decision tree, etc. If it's, for example, a boosted decision tree where you're going through multiple iterations to get to improve it as it goes through. So there's lots of parameters metadata parameters that you need to, hyperparameters that you need to change to play around with to try and get the best out of it. So think about different features in a car. We might think about the mileage, car brand, etc. And the algorithms that we might use with the parameters. So what we've done with AutoML is we kind of take all this pain out for you. So it will go through, it will try different algorithms, it'll try hyperparameter tuning, it'll try different features, and then it will bring a score out at the end of it, and then it will learn from that, and it'll go, right, okay, we'll try a different algorithm. And it will go through this and iterate and iterate and iterate until it's gone through X number of iterations. Normally we say it's probably 100 to 150 iterations is quite a good set to get a reasonable model. And at the end of that, you could go, okay, so I know a support vector machine is going to be the best model, so I might just go off and use support vector machine, or you might use the AutoML model that it created for you, and then every time you retrain using AutoML to go through this process, but you might just use it for information. So it takes a lot of the pain out of a data scientist's job, and obviously you can pipeline this and put it into as part of MLOps. The data comes in, you do AutoML on it, you get the best model. That best model you take and you operationalize that model. Okay, so let's yeah, let's jump into Azure Machine Learning Studio, and I'll show you some examples of the stuff we've been talking about. So this is Azure Machine Learning Studio. This is the home page. Um, what I'll do is I'll run down here, talk about the more common components, and then we'll go in and we'll look at some of the Python SDK as well. So it's just how are we doing for time? We're pretty good. Okay, good. Um, okay, so let's start with notebooks. So notebooks are a way. You're probably familiar with notebooks. Um, Notebooks are kind of it's changeable. You can take your code and you can use it in different environments. Same with here. We've got our notebooks, and you can download the Python, and you can the notebook except and put it onto local, or you can take notebooks and upload into here. So this is probably where you're going to be doing most of your work in terms of if you're creating models, etc. So in here, I have a example, a notebook. We can choose the kind of compute to run on. We can also, in here, we can create new compute. So this is, let's call it demo. And we can choose if we want it to be a GPU compute or CPU compute. We've got all the different VMs in here, and so this is basically how much power do you want to throw at this problem. How much power do you want to do in your training of your model, etc. So normally I would probably go for quite a small one. The default is a 4-core, I think. Yeah, it's a 4-core. But if I was doing a deep neural network, I might go to the GPUs and speed up the training of that. Okay, so we can also set up have it part of a virtual network as well. And that basically gives you the compute level of your notebook. So like I said before, just leave that. Your notebooks are held on local in blob, sorry, in the resource group in blob storage. And then when we attach to compute, we just tell it which compute that we want to run against. We've got some other nice things in here. We have things such as should have things such as IntelliSense in here. So, for example, you can see there that I've done a comma, and now I can see the train test split. What's wrong there? I can see that as I've started looking at this notebook, it's I've got error reporting, so I can see here that I've actually instead of CLF.fit, I've put CLFA. So now it's saying, oh, hold on, you probably didn't mean to do that. You've got a CLFA doesn't exist. So go in there, change that. Everything's good. I can also go in here and we have IntelliSense. So I can see all the different things. If so, dot and then fit should work today. So we have IntelliSense in there as well. And we can run in here. So click on that, we run. We've got other new things coming in as well, such as the ability to co-author notebooks, so two people working on the same notebook at the same time. And all the standard operations that you would have in a notebook. However, if you would rather not use this particular implementation of notebooks, you have the ability to run off and run up in Jupyter Labs or edit in Jupyter. So I've already got a couple of tabs here, which ones I'm going to show you. That's running in Jupyter. And Jupyter Labs, obviously you get a little bit more in terms of on the left hand side, we'll get all the different notebooks in there once that spins up. Okay, so let's go back into here. We also have sample notebooks in here, pretty much samples. So actually, as I said before, we have on our SDK as well. We're only talking about Python today. So we've got tutorials, how to do different things, most things that you could possibly want to do. Reinforcement learning, we've got things such as how to do pipelines. We've got how to run deep neural networks. We've got PyTorch examples, Keras examples, and examples basically for everything. So this is just linking back to a Git repository. Oh yeah, also should mention that this that when you spin up notebooks, they also have Git installed. So if I go in here and I open a terminal, I can go in, I can go straight onto the box here, and from here I could say start doing Git commands, and as you can see, Git's installed, and I can do once I made my changes, I can commit them to Git, I can get the latest version from Git, etc. So all kind of thinking about versioning and how you might do a traditional project in terms of source control, etc. Okay, so yeah, so I've probably talked about all that. I'll show you this briefly. So this is AutoML. So this is a wizard that lets you do AutoML. So basically you'll go in, you choose a data set, and you choose what the problem is, if it's a classification problem or regression problem or forecasting problem. You would so let's just give it any old data set, and you choose a compute to run it on. I'll talk about computes in a bit more detail. Let's do that one, and then target column. Actually, that was a bad example to choose. Let's choose that one, and in fact, these are bad examples of data that I've done in here. Okay, but so you go in and you click next, and then it would ask you for if it's a classification, a regression, time series forecasting. We also have the ability to do deep learning now as well, so deep neural networks for classification. Time series, we have the ability, as you set, which is your time series column, etc. And then when I click finish, that will go off and run the experiment. Like I say, I'm not going to run it this way using the wizard, just showing how easy it is to create AutoML experiments in that respect. I'm going to show you through code how you do it, which is a pretty simple thing to do. This is our designer. I'm not going to go into this in too much detail. If you've used Azure Machine Learning Studio, you were probably, as in V1, you're probably familiar with this. Basically, you have your ability to push drag and drop. So if I wanted to, I might do import data in here. I might take that and do a split of that data. And then, as you can see, I'm just creating a pipeline. I put maybe a training, in fact, train model. We would have a score model, we'd have a train model. I'm not going to go into this in depth because for time purposes, but as you can see, drag and drop, and you can choose the one of the problems with the original version of this was that you're kind of in a black box. You had to choose the compute. You couldn't see the code that was produced at the end of it. This is different. When we run this, it creates an experiment. You can choose how you want it, where you want it to be deployed to, the actual compute that you want it to run. So you can choose how much power you want to give it. So for example, I could select a different compute target here, and I can choose which one of my clusters I want it to run. So we've got a lot more power behind it, and it's a lot more open in terms of letting you choose the power and then seeing the end results and seeing the code at the end of it, etc., and maybe taking that off and doing something else with it. But like I said, I'm just not going to go into that in too much depth because we won't have enough time to cover everything we need to cover. Now, data, I will talk about data labeling, but in a bit. So data stores, so these are links to external kind of metadata links to external data stores that we could then use. So I could go in, as you can see, I've got sort of blob storage, I've got some SQL in there, basically just connections to my data, which I then might use with my data sets. So my data sets, I could create a data set. I can bring it from create a data set from my local from my data stores, from my local files. We've also introduced open data sets. So if you want to start playing around with something, these are all here. The traditional ones such as New York City taxi, if you want a big data set, diabetes data set, etc. So you can bring them in, just kind of open data sets if you want to as well. For my files, yeah, informative data sets, talked about that already. So these are our data sets. If I go into one of these, your kind of hello world iris data, I can see that where that data set sits. So this is now sitting in my blob storage. Like I said, as part of that resource group. I can have different versions of that data set as well. I can, if I wanted to run that data set, we give you the code so you can actually access it. So that's the code to get into, that's my subscription and my resource group, and then that's the link to the data set. So it gives you the nice Python code to do it. I could look at my data set so I can see what it looks like. So this is obviously the iris data. Well, it's a bit of a mess, this one, but it's supposed to be the iris data. And oops, I should jump back to explore, and then I could, if I've profiled this, which I might, yes, I have profiled this, and then you can generate a profile, and then you can see the lay of how that all the data looks. So we get an idea of, histograms, etc., etc. Now, experiments are probably one of the kind of critical parts of this. So experiments lets you see how your when you're doing a machine learning experiment, it records all the metadata. I'm going to show you the code first, then we'll jump into experiments. Pipelines are, I probably don't have any good demos of pipelines at the moment, but these are basically your ML ops. So you would construct a pipeline. Let's just see if I have got one anywhere. If you'd construct a pipeline, and then you'd effectively, okay, so here's an example, very simple one. So that's bringing data, and then it's running, I think this is running some Python code then on that data set, but you can have this in serial, in parallel, and you can construct a whole kind of tree of all the steps running off all the different computes, etc. We have our models. So where we've created models now, this is a bit of a mess. Is this my kind of mess around but workspace. But when we create a model, we register it. It will come into here, so we can see all our models. So, for example, this model, I could take this. I could then deploy it off into this way. So I would then choose my script file. So this would be a script of my Python script. So I'll be turning this to a web service. So this would be my Python to be able to how's the JSON going to come in, what's it going to do, how's it going to push it out, etc. Compute targets I want to push it onto, etc. So I can deploy this way. I'm going to show you that in code in a minute. So my models, where I might, if I got a chance, we'll talk about explanations of fairness. So the ability to make our models explainable, and if we have fair learn as well, so we can have a model and we can see if there's what biases there are in that model. And then these are endpoints. So for example, I've got a Azure Kubernetes instance here, which is a web service, and I'm going to show you the code to get to that. So before we jump into code, show you different kind of compute. So this is Azure Compute. So this is where I'll be running my notebooks from, but I can also use this and spin up Docker images on these as well. I've got some that are GPU, some that are CPU. And so I'll be running on probably one of these when I show you the demo. We have our clusters. So clusters are, if we've got a lot of data, we want to push it off and run it on kind of remote compute. So things such as, so this one, for example, is a 20 node cluster. So this one's a 20 node cluster. This one is a little cluster I just keep with one node always on. So it's, I don't have to wait for any kind of spin up time. I've got GPU clusters in here as well. So if I wanted to go off and do a big experiment, I would run off on this compute clusters. So this is Azure Compute instances. These are inferences. So this is Kubernetes. I don't have any Kubernetes services running because the benefit of clusters is that they shut down when you finished using them. So as you can see, none of these have any nodes up. None of these are costing me any time. So I've got this potential to run this GPU cluster. This is N6, I think. And it's will go up to, if I just click on edit, it will go up to 2 nodes, this one. And then if it's not doing anything for 120 seconds, it will just shut down and turn itself off, and I'll only have to pay for the time that cluster was up. So have a lot of power at your fingertips, and it's not going to cost you much. It's only going to cost you for when you use it. And then we have our attached compute, so we can go off and talk to virtual machines, Databricks, HD Insight as well. Now, most things we're going to be doing in this compute instance. So it's wary of time. Let's quickly jump in and actually show you some code. So for this example, this is using AutoML. So the first thing I'm going to do is I'm going to look at make sure look at the version of the SDK, so the Python SDK. I'm going to go in and I'm going to connect to my workspace. So I've loaded this in from my config. I'm going to create an experiment name. And then this is giving me basically print that out, so it shows you my workspace. I misspelled when I originally created my workspace. I misspelled it, but that's quite a good thing now, because I know if I type workspace incorrectly, I only come to this workspace. So um, it was wrong thing to do, but it actually is quite useful to have it misspelled now. Anyway, so that's my workspace. This is my experiment name. So anything I do in terms of this experiment will anything I do in terms of this experiment will go into, and all that metadata will be recorded under AutoML Sensors 3, which will be under my experiments, which again I'll show you in a minute. So load in, like I said, I'm not, as you can see, I'm not doing any pip installs. I could do something like, whoops, I could do something like exclamation pip and do an install that way. I could actually, when I think about it, I could do git pull as well, just to make sure that I've got everything, all the latest versions here. I'm up to date already. So I could do this, but I've already installed these. So this set of data is the adult census data, which is quite a common data set that we use. It's quite a nice data set because you can get about 80 plus percent accuracy, but it's not too easy a machine learning problem like the Iris data set, where if I use AutoML on Iris, I've probably get 100% in the first 2 iterations. So it's too easy to predict. This is the kind of next level of simplicity, so slightly harder to predict. So this one we're looking at people and their ability to if they're eligible for loan. So so all these different people in here, and if they can have a loan. So it's the classification, 2-class classification problem, loan, true or false. So that's what my data looks like. And we've got things such as relationship, race, sex, capital gain, marital status, etc. This is quite a good data set as well for doing things around Fair Learn, because there's a lot of bias in this data set. And if you run this through things like Fair Learn and explainability, you can see that bias coming out. So what we do, split the data into test and train. So we end up with 24,000 records for testing, 6,000 for training, and then we get to our AutoML config. So this is where we are defining the settings. So how many cross validations, the metrics. So I'm going for accuracy. You could go for try and work for precision or recall. If we're using this is a classification problem, I've tried this classification. If this is a regression problem, I might then say something. I might say R2 score, root mean squared error, all the traditional things it can work towards. It just needs to know what it should be working towards. So I've kept this simple and said work towards accuracy. We want the best accuracy that we can possibly get. We also have time series forecasting as well. So if you're doing time series forecasting, you'd then be putting in your time series column in here and any kind of grains within the data, etc. If we're going to enable Stack Ensemble, so this is creating ensemble, basically creating the last thing it will do if we have this enabled is it will create a model that uses it's a collection of models, and all those models are voting for the answer. So usually that gives you quite a high level of accuracy. I've just turned it off for this example. I can't remember why, but we do have all that kind of ability to do that, decide what models you want. If you wanted to create ensembles, for example, I could blacklist models. If, for example, I know that k-nearest neighbor overfits the data, I could go, well, let's not touch KNN for this one. Just through. Iterations, this is a really simple one. It's given it 6 iterations. Like I said before, you probably want to do 100, 150 to get a real sense of the best models that you can do. And so what I've done here is I've run it locally. So that there's you can run it on different compute. This one's local. I'll show you later on. I'll show you how to run it on across larger sets. So it's running it locally. As you can see, I've run through multiple iterations, and I have my 6 different ones here. Voting ensemble. So I told it not to do a stack ensemble, but I still let it do a voting ensemble. So I can see the voting ensemble is actually the best one. I can see that my accuracy is pretty high. I can click on these and get more metadata about them. So things like area under curve, there's my confusion matrix, etc. So that's running locally. I could then, in fact, let's look at all the data associated with that. So if I wanted to look at the position, etc., I can run through these and get the best, get all the runs, and then return the best run of this, which is going to give me, in my case, my voting ensemble. I could test that data, and then and so I can see the confusion matrix, how good it is. This example, we're pushing off onto a cluster. So this is ACI. So we've gone in, we define the min and max number of nodes. We put our training and testing data into a data store so the cluster can pick it up. Then we set the, so that's just connect to the data store. And then we set up our run config, run through that. So I'm going a bit quicker now, just because cautious of times. Set up our run config, again, classification, slightly different. You can pause the video if you want to see that in more detail. But this is all part of the, all already held out in Git or in those samples as well. So there's lots of similar examples of this. Run the AutoML. As you can see, I went through this case. I went through 20 iterations. These all ran in parallel. So I went across a node that had 20, a cluster that had 20 nodes on. It ran all those 20 nodes at the same time. I had a few failures for some reason, but as you can see, I ended up with only a couple of failures. And then I can see all my different iterations that it did, and I end up with a model in this case that's the best model, which was in fact in this case the metric was 85% of max ABS scalar. Interesting. Okay, so that's AutoML. And we can go and look at the experiment in AutoML. So it would have been, this one was the one we spun off across a cluster with our experiments. So it's this one. We also have, it also implements data guardrails, so it makes sure that your data is good. So things like split handling, make sure that the classes are balanced, missing features, all this kind of stuff. In there, we can actually look at the models that it ran. The one that it does the most accuracy on, it will create an explanation for. So we can go in and we can look at this data and understand a bit more about how it created these models. So we look at explainability, we can look at the importance of the data. So marital status was the most important one. We can look in at how that splits down. So capital gains seems to be the difference in capital gains influences, and we can see the local feature importance. So we can click on individual ones of these to understand how each single point was calculated. So massive amount of information about your model to understand it in more depth. And we could take this output from this and we could push it onto a web service. So what I've done here, I've just run an Iris data set. I won't go into too much details, but basically I've run a few iterations of an Iris data set. So this is going in training the Iris, and if I go back to my experiments, this will be this one. We also had, so I did 3 runs for this, and we can see I actually got more higher and higher each time I ran it. So we can also choose which charts and stuff we want to add into here. I can see run 3 is the best run. Within run 3, I can see the model that it created. I can download that model. It's just a pickle file. I can see the metrics that we've run. So again, all this metadata. I can see a snapshot of this. So this is what my code branch looked like at the time I ran it. So I could go back. It's a bit messy, my code branch, but I could go back and just take this out, and it's the code that gives me this level of accuracy. Because we don't have time to go through any more about explanations of fairness, but that's in there as well. So what I might do in code, so I've run through 3 experiments trying to get a level of accuracy. I then run through all of my models to get the most accurate one. I might have done 1,000 experiments, so I just run through this bit of code. This will give me the most accurate model. And then what I might do is I might turn it to web service. So to turn it to web service, I will create a scoring file. So this will be able to take the web service in as JSON, process it, push out the results. I'll go in and tell it the environment. So I want scikit-learn and Pineapple in my environment. So this is going to create a Docker image that we'll push out into a web service. We told it the environment we want. We tell it the actual Python file it's going to use for scoring. These are different options for pushing out. And in this case, we'll use a Azure Kubernetes instance. Oh, sorry, Azure Cluster instance, ACI. I could run it locally as a Docker image, but I'll use ACI. We run that. It takes almost no time, 2 minutes to spin that up and run it. I can look at the logs in there if anything goes wrong. So we've got complete control over it. You can look at everything that's there. And I can go in and I can get the web service URL. So this is now my new web service that it's created. Like I say, just an Iris model that run the Iris dataset, trained a pickle file, put that into create an environment file so it knows what to run, put that pickle file and that environment file on an image, push that up there. This is now that running image. And it's Iris, so I can go in and see run predictions against it. So obviously it's a web service, nice and quick, and I can go in here and I can see my web service is in, where is it? Compute. No, it's not. It's in endpoints, and so there's my web service. Right, now I am over time, so hopefully that's given you a overview of what we have in terms of Azure Machine Learning service. There's lots and lots more to it. This was quite a whistle-stop tour. I hope you found that useful, and enjoy the rest of SQL bits.